Alright, we're having a look here at electric circuits. We're looking at series circuits and parallel circuits. But before we start, we're just going to go through some of the basics just to help you get through whatever you might not understand. So the first thing we have here is we have the series circuit, and inside your series circuit, you're going to start with a battery or power source. And that's going to be your energy supplied. Now, how we measure the energy supplied is we use this voltmeter. And this voltmeter always shows the total voltage, or it's the energy we have. Okay. We then have your entire circuit, and then we've got light bulbs here. And these light bulbs, and you don't have to only have light bulbs, you can also have resistors, but these light bulbs have their own resistance. And if it has resistors, it means that work is being done. Okay, so something needs to happen inside of those light bulbs. To measure what work is done or how much of energy was used up, we have these voltmeters here, and they show us the energy used up, or they show us individual voltage, okay, for each resistor. And through the circuit, you have going from the positive terminal to the negative terminal, you have your current. So three things that are important to us is voltage, which we measure in volts. We've got resistors, which is always measured in ohms. And we've got current here, which is always measured in amperes. So that's the first thing. Right? We'll go through the breakdown of each thing, but we're just looking now at what's happening in the circuit itself. Like, what do you have included in your circuit? Again, here you have in your parallel circuit, you have a battery or a source, a cell, we can call it, or a source. Right? You also have a voltmeter here, and that gives you your total voltage. Again, light bulbs, these are your resistors, right? And they determine their own current, which we've already looked at. Right, and over these resistors, you have voltmeters, and they get the full energy supply from the battery. Okay, so those are your two types of circuits. You still have voltage, you still have resistors, and you still have going through here, and I'll show you how this looks. You still have a current that's going through the circuit, doing something like that, and you have the other current that's doing something like this. So that's your branches. So usually in a parallel circuit, we have branches, okay, and these branches have resistance, and they all have their own current. So each branch has a different current, and it's all dependent on resistors. So we're going to have a look at a summary of what's happening in each circuit. Something we've done already, but important for us to just check again. Okay, over here, we've got our series and parallel circuit, and we're just going to break down each one. So I'm going to start you with the series circuit. And in your series circuit, you have a total voltage. Okay, this total voltage is VT. That's what's going through your entire circuit. That's how much you have available to you. Now, this voltage here must get used up. So if I have to look at it, let's say I had to run a current through the circuit. So here goes the current, and I'll use a highlighter or something just to show that that current is going through the entire circuit. Okay. Now, when that current is going through the circuit, this is what I'm actually seeing. It's going through all the components that are connected in the circuit. So if I had to take a reading, let's say I1 there, I had to take another reading, I2 over there, let's say I3, I4, even I5 if I wanted to. That would be my current reading. All right. Now in this circuit, the current's going, there's one color, which means there's one current or one color going through all the components. So we can sort that information out. We can say that for these circuits, if I wanted current, I could say that I1 would be equal to I2, which is equal to I3, which is equal to I4, and so on. That tells me that the current is the same through all parts of the circuit. Okay, so that's the first thing, current. And the second thing that happens is each of your resistors or each of your light bulbs over here, they're going to offer some sort of resistance. So I should get an X amount of ohms here and let's say a Y amount of ohms here. So inside your circuit, because the same current is going through them, then when we look at resistance in series, we can say that the total resistance in series is equal to the resistance of R1 plus R2 plus R3 and so on. All right, so all we're looking at is a sum of all resistors. All right, and the reason why they all can just be basically added together is because they have the same current going through them. All right, then the last thing that we're looking at is voltage. So voltage total over here is how much we have. Okay, but over here when I look at the voltage, this is how much we use. Okay, now in this circuit, when I talk about voltage, I can say that for voltage, I can say that V total is equal to V1 plus V2. So the voltage will split. Okay. So it must be shared, not equally, but shared between the components. And again, because voltage is all about energy, then it depends on the resistors. Okay, because the reason for that is each resistor, remember what I said to you, if it's a 2 ohm resistor, then maybe the hill would look something like this. If it's a 5 ohm resistor, maybe the hill's going to look something like that. If it's a 10 ohm resistor, maybe the hill's going to look something like that. So depending on these resistors, they are going to end up using energy. Okay, so in essence, what we want to say is that in a series circuit, the voltage or the total voltage must all be used up. All right, we don't want anything to be left over. I'm going to show you some calculations when we get through it. So those are your 3 summary points for current, resistance, and voltage in series. All right, when I go here to my parallel circuit, that works out a little bit differently. So for the parallel circuit, remember we spoke about this. Again, you're going to get total voltage. And that's going to be your V total. Okay. Now in this circuit, the current gets drawn a little bit differently. You could have a current. I'm just going to use a highlighter. you could have a current that comes straight out of the battery or the cell, and it goes through the first resistor, which is on its own individual branch that we spoke about, and back to the negative terminal. At the exact same time, you have another current going out, and that current is going through the other branch. So that's what you have, two colors, which means you have two branches. So what's happening here is that at this point here, the current splits. Okay, so technically, if I'm looking at my current for the one, that's what it looks like. Okay, and for the other one, it looks like this. So now we can isolate certain areas and say, in some areas, like over here, for example, or over here, for example, there's only one current. But in other areas, for example, here, or if I look here, or even there, I can see two currents. Okay? So where I see two currents, that will give me my total current. Okay? Where I see one current, it's the current in that resistor or in that bulb. And it's the same for both of those. All right, so the first thing that I want to see here is if I had to say I1, I2, I3, I4. So if I had to take readings there, here, here, and here. All right. Now, the colors matter because the colors tell us how many currents are going through that point. 2 branches, 2 currents. 3 branches, 3 currents. So the first thing I'm going to look at is current. And I'll notice here for current is that I1 is equal to I4 because they have 2 colors going through it. Okay? But if I see those 2 colors, the one color is like a purple and the one's a green, which tells me that if I wanted I1, I'd have to add up I2 plus I3, which also gives me I4. All right, so this here is the current in each individual resistor on a branch. Okay. This I over here is the total current. So in a parallel circuit, the current will split. And how do I see the split? I use a highlighter. Don't be afraid to use a highlighter. And the next thing we need to look at is the voltage. Now with the voltage here, your total voltage, your VT, right? So let me just sort this out. Sorry, add here, this is V1 and this is V2. Okay, so I've got my total voltage. And this total voltage, because they are branches and the current will split, it means that all resistors receive all of the voltage. So therefore, your total voltage is equal to the voltage on V1, which is also equal to the voltage on V2. So this total here is available to resistor 1, and all of it is available to resistor 2. So all available to all components. Okay, so that's your voltage. And the last one here is the resistance. Now the resistance is a little bit different. In the resistance, your formula is 1 over Rp total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 dot dot dot. So this here is the total resistance in parallel. Okay, so if I wanted to find the total resistance, I'd have to use this formula, but there's something special about this formula, which we will have a look at. So there's your little summary for current. Okay, so current, then voltage, then resistance. So remember here in this instance here, the resistance, if I have a high resistance, then I'm going to have a low current. So if I have a big resistor, it must get a small current passing through it. So that's your one rule that's very, very, very important. All right, so let's have a look at an example. So what we have here is 3 circuits, and what we want to do is we just want to determine what kind of circuits we have. So always with a highlighter, we start with A, right? So it goes from here, gets to a point, goes through here, and out there. I take another highlighter, it goes down here, goes through here, it goes up across, it comes back here. And for the last one, it goes through here, over here, and back. So I can see now, because I had to use 3 highlighters to get through all of my components, it tells me I have a parallel circuit. Now with the parallel circuit, the formula is 1 over Rp total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, the only reason I have 3 here is because I've got 3 resistors. So what I want to do now is, just remember that this also means the equivalent resistance. Okay, so if they ever ask you for equivalent resistance, all they want is the total. That's important. So I'll say 1 over Rp total is equal to 1 over R1. Oops, R1 is 7 plus 1 over 5 plus 1 over 2. So what you want to do now is just put that into your calculator. And when you put it into your calculator, you're going to get 1 over Rp total is equal to 59 over 70. Okay. Now here's your problem. What we are looking for is we are looking for that, not the fraction. So now we're going to get this out of the fraction form. Now the only way to turn this fraction into a whole number is to put it over 1. Now it's already 1 over. It's 1 over Rp total. But I want just Rp total. So what I'm going to do is I'm going to swap that around. And that becomes Rp total over 1, which is actually, if I look at it, is Rp total. In fractions, we don't have to write over 1 because over 1 means it's already a whole number. Now, if I swap on the left-hand side, I must do the same on the right-hand side. So if it's 59 over 70, I've got to swap it over. So now that equals to 70 over 59. And if I put that in my calculator, I should get 1.2 ohms. And that's how you work out total resistance in a parallel circuit. Now the trick here is that if I'm looking at RP total here, in a parallel circuit, the total resistance must be, this is important, must be smaller than the smallest resistor. So in this circuit here, okay, the smallest resistor, so one of the R, I think it's R3, is equal to 2 ohms. But RP total, that's equal to 1.2 ohms. So your total resistance can never be bigger than the smallest. So this is the smallest resistor. And this is the total resistance. And if your answer is ever bigger than the smallest resistor, then it's an indicator that you have done something incorrect. So that's how you work out in a parallel circuit. So that's the answer for A. Of course, you'll have to do practice, but I'm just showing you how to work this out. All right, if I look at B, again, what I want to do here for B is I want to go from the positive terminal to the negative terminal. So I'll draw my lines. And what I'll notice is for B, when I went from the positive terminal to the negative terminal, I passed all the components, which means that tells me I have a series circuit. Also, one color means series, many colors means parallel. So for B, we're going to say R, the total in series is equal to R1 plus R2, since there's only 2 resistors. And that's going to give me 2 plus 5. And the R total in series is now 7. Oops, where am I going with that? 7 ohms. Right, nice and basic. You just have to add the resistors together. I go to the next one. And I start here at the positive terminal and go through the whole circuit. Again, I would have noticed that only one color, but with that one color, I managed to pass through all the resistors. So that again is a series circuit. Okay, which means for C, I'm going to say RST is equal to R1 plus R2 plus R3. So this time I had 3 resistors. So I've got 7 plus 5 plus 2. And the R total in series is then 14 ohms. Now this is quite interesting actually, because what I want you to notice is that if I look at example A, it had 7 ohms, 5 ohms, and 2 ohms. But the total was equal to 1.2 ohms. If I look at if I look at C, it had 7 ohms, 5 ohms, and 2 ohms. So if I look at the R total in series, that gave me 14 ohms. So now if I'm looking at it, if I use the exact same resistors, when I connect it in parallel, there is going to be less resistance in parallel. Okay, whereas for series, if I put the exact same resistors in series, there is more resistance in series. So by connecting resistors in parallel, it makes the circuit more efficient. So it's better to have resistors in parallel than to have resistors in series. If you look at the difference there, 1.2 versus 14, there's a huge difference. So what we don't want to have is series circuits, because series circuits, so if I have a series circuit, parallel, oops, let's just get that right. If I have a series circuit, I'm going to end up with more resistance. So it becomes an inefficient circuit. So that's what a pattern that you should also notice. Right, so that's how you work out total resistance for series and parallel circuits. Alright, so if we had to look at series circuits, let's have a look at these two series circuits. You can get the drawings into your books. And what I want to do is just want to add in over each of my resistors. That's resistor 1, so it gets V1. And that's resistor 2, so it gets V2. Over here, again on this side, I've got V1. I've got V2 over there. And then over here, I've got V3. Okay. So I want to add those voltmeters in, and they've given me the resistance. And we need to find all of this information that's blank. All right, so the first thing that we need to understand is what kind of circuit. Take our marker and we run it through. So let's get that nice and thicker. And we run it through. So let's have a look at the color that. So if I run my thing, my highlighter from the positive to the negative terminals, you will notice that the highlighter goes through all of the components. All right, so let's start with the first one. They want total resistance, so they want R total in series, and if it's series, it's going to be R1 plus R2. And over here, I've got 10 plus 20, and that gives me RT is equal to 30 ohms. So I'll go here and I'll say that answer is 30 ohms. Now they want I total. Okay. So for I total, I know that for total, if I can find I total, then I need two things. I need the resistance total and I need the voltage total. Because then I can use R is equal to V over I. So what I want to do now is I'll say for my whole current, for my whole circuit, I know that the total resistance is equal to 30 ohms. I know that my total voltage is equal to 90 volts. And I also know that I'm looking for the total current, which I don't know. Looking for IT. Okay. So all I'm going to do is I'm going to start with R is equal to V over I. Always get a mark for that. The resistance here is 30, which is equal to 90 divided by I. And remember, you always have your triangle that you can work with, where R is equal to V over I. So all we're going to do is say I is equal to 90 divided by 30. And that gives me I is equal to 3 amperes. So now I've got the total current, which is 3 amperes. All right, now they want I1 and I2. But if I look at the color in my circuit, if my I total is equal to 3 amperes and I only have one color, it means that the current is the same everywhere. So if I had to check and I said, let's say that was I1 over here, and I said that over here it's I2, then if I look at the area where I1 is and the area where I2 is, I still have the same color. So if I total is 3 amperes, then I1 is 3 amperes and I2 is 3 amperes. So now you've sorted out your current. The next thing they want is V1 and V2. Okay, so they want how much energy did this one use and how much energy did this one use. Okay, so we're just going to go here and we're going to say to find voltage, we still going to use R is equal to V over I. So what do I know about R1? Okay, R1, I know about R1, if I go up and check, it's 10 ohms. Okay, and the current that's going through it is equal to 3 amperes. What I want is V1, which I don't know. So all I'm going to say is R is equal to V over I. The R is 10. V we don't know. And the current is 3. So if I wanted to find the voltage, all I'm going to say is V is equal to 10 times 3, which means V1 is equal to 30 volts. Okay, so I go back to my diagram and I fill in here that that is 30 volts and also this answer is 30 volts. Now to find V2, it's quite a special situation because V2, there are two methods. Okay, I'm going to show you the two methods. Right, for V2, the first thing we can understand that is that in series, we have the voltage splits between the resistors, right? So I know that Vt is equal to V1 plus V2. I also know that where V2 is, R2 is equal to 20 ohms and I is equal to 3 amperes. So that gives me two methods. So in the first method, what I could have done is I can say R is equal to V over I, where this is 20 and this is equal to V over 3. And I can say that V is equal to 60 volts. Okay, that's method 1. The other option I have is, because I know the total voltage, which is 90 volts, I can say 90 is equal to V1, which is 30, plus V2. Because remember, because the voltage will split according to resistance. Okay. So one resistor is bigger than the other. It's double actually. So we're going to look at that pattern as well. So now I'll put like terms on one side and say 90 minus 30 is equal to V2. And V2 is equal to 60 volts. So if you use the two methods, regardless of whichever method you use, you're going to get the same answer. So if I look here and I say, if I look at a pattern that I see now, if I say R1 is 10 ohms and R2 is 20 ohms, then from here to here, there was double the resistance. So let's go from here. From here to here, we had to double, or we had to times it by 2. So if the voltage here is 30 volts, then the voltage here has to also be times 2, which gives me 60 volts. And if I add 30 and 60, I get 90 volts. And that was the energy supplied. So I can see that pattern that's formed now, that the voltage does split in a series circuit. And it should give me the total voltage, which is this formula here. So that's how you work out different parts of your series circuit. So I go back here to my diagram and I enter this as 60 volts. And now I can go ahead and do the same thing over here for this circuit, which I think on this circuit, you can do this circuit by yourself. So now I'm going to show you the parallel circuit. Alright, so if I have a look here at this circuit, the first thing I want to do is I do my colors, right? So the first color goes through here, goes through the 18 ohm resistor, goes back here, right? The second one starts here. See the colors? Sorry about that. Goes through here, goes all the way back. Third one starts here, goes through here, back here. Last one starts here, goes through here, comes back. So when I have something like that and I've got so many colors, then I know that the circuit is parallel. Alright, so there are many different types of questions they can ask you. The first question they can ask you is to find the equivalent resistance. So all they want here is the total resistance. So the first thing you're going to go and say is 1 over Rp total is equal to 1 over 6 plus 1 over, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Now you have 4 resistors, you get a mark for that, so that's important. You need to make sure you sort that out. Then you've got 1 over 6 plus 1 over 12 plus 1 over 36 plus 1 over 18. All right, just put all of that into your calculator. So you've got 1 over Rp total is equal to, and that gives you 1 over 3. Now you want Rp total. So Rp total, and what we're going to do is we're going to swap that, is equal to 3 over 1, not 1 over 3. Rp total is then equal to 3 ohms. So that is your total resistance of this circuit. All right, the second question they can ask you is they can say find the value of each current through each resistor. All right, so what would be important for us to know here is I have total voltage, and that's equal to 12 volts. Okay. Now what's important about that is when I go to each of my resistors, V1 could be 12, or is rather, V1 is equal to 12 volts, V2 is equal to 12 volts, V3 is equal to 12 volts, and V4 is equal to 12 volts. Because in a parallel circuit, they all get the 12 volts. So that's another little bit of information that I know. And on top of that, I also know the resistance for each of the resistors. Alright, so I can start and say R is equal to V over I. So I've written my formula down once, and that's enough. Okay. So now I need to find the current. So I know that I is equal to V over R. So I've already got that one mark. I can't get the mark again. So I can go and just do this. I can say 12 divided by 6. And I can say 12 divided by 12. And I can say 36. Oops, sorry. 12 divided by 36. And I can say 12 divided by 18. So those are my options. So for the first one, going through the 6 ohm resistor. So those are all your ohms. And those are all your voltages. It stays the same, 12. So for the first one, 12 divided by 6 is going to give me 2 amperes. That's the first one. 12 divided by 12 is going to give me 1 ampere. 12 divided by 36 is going to give me 0.33 amperes. And 12 divided by 18 is going to give me 0.67 amperes. Right, so there's all my currents going through each of the resistors. So that's the first thing. Right, or the second question they can ask you. The third question they can ask you is they can ask you to find the total current in the circuit. Okay, so there are two options. Okay, option one, if you know total voltage and you know total resistance, then you can find total current. Okay, that's what we're looking for. Or you can use some of your theory and you know that the total current is equal to the current in the 6 ohm resistor plus the current in the 12 ohm resistor plus the current going through the 36 ohm resistor plus the current going through the 18 ohm resistor. So what you would notice here is I use a subscript, and that tells my marker exactly what I'm adding together. So for method one, do I have total voltage? I do, over the battery. My total voltage is 12 volts. And do I have total resistance? I do. And that gives me 3 ohms. Okay. So I can therefore say R is equal to V over I, where the resistance is 3 and the voltage is 12. And I've got I over here. And therefore the current in this circuit is equal to 4 amperes. Okay, so that's method one. Method two, I can add up, to get I total, I can add up all my currents. So I can say 2 plus 1 plus 0.33 plus 0.67. So if I add that all together, and you just put it into your calculator, and if you add all of it together, I total is equal to 4 amperes. So regardless of which method you choose, you can still find the current. This method here, you must have all total values. You can't just have random values. You must have the total current, the total voltage, the total resistance. The other method, you can use all the information on the branches, because in this one, if we add up the current on each branch, right, we'll get the total current. Okay, so if you look here at your circuit, when I'm looking at this area here, in this area I've got 4 colors going through it. That area there I've got 4 colors. Over here I've got 4 colors. But those 4 colors are green, orange, pink, and purple. So green, orange, pink, purple. So the colors coordinate with each other. They correlate with each other. So that is how you can work out. If you're looking at a parallel circuit, those are the different types of calculations that you can do. Now what you've got to do is, you're going to go into your textbook and you need to complete all activities for the electric circuit chapter. Okay, you then need to submit all of that. Once you submit all of that, then I can send you the memo. Please try and do that as soon as possible.